Thank you for joining me. I'm glad you are there. Today I want us to look at the reflection of light at plane surfaces. We start with the definition of term, reflection. And of course, we know that reflection is nothing but throwing off of light or throwing back of light when it hits a plane surface. For example, if this is a plane surface and if light hits on it, now of course this light, part of the light, three things will happen. Some portion of this light will pass through, number one. Number two, some portion will be absorbed by the surface, and then number three, some part of it will be thrown back. Now, our interest today is this portion that is thrown back, which is reflection. So, in other words, we can now say that yes, reflection is nothing but the throwing back of incident light from a plane surface. Okay. Now, if we have this as our plane surface, this side is the silver surface. And of course, the typical example of a plane surface we're referring to is the mirrors. And of course, there are two types of mirrors. We have the plane mirrors and we have the curved mirror. Number one, plane mirror. Plane mirror. Number two, we have the curved, or otherwise known as a spherical mirror. Otherwise, or spherical mirror. Now, these spherical mirrors are divided into two. We have the concave mirrors and we have the convex mirrors. But for this lesson, we're going to concentrate only on the plane mirrors. Now, in our next video, we'll look at spherical or curved mirror. Now, back to what we are discussing. Plane mirror. If this is a plane mirror and we have the two sides, this silver side, which is the back, and then we have the front, which is a reflective surface. Now, if light is incident on this, the first thing we do is we draw a normal line. Let's say N0 here. Now, this is the front, the reflective surface. This is the back, the silver surface. Now, if light is incident, we have our incident light, so we can call this incident ray, or otherwise incident light. Now, we have the second part, which is the reflected ray. By this, an angle is formed here. Another angle is formed here. Now, this side, this is the angle of incidence, which is the angle between the incident ray and the normal line. Now, we have our reflected ray. The reflected ray is the angle formed between the angle of reflection is the angle formed between the reflected ray and the normal line. Now, we have this as our glance, angle of glance. And of course, here is still equal to this place. So we have here as our glance. Now, assuming we have this, we have the ray. If we have this as transmitted ray, or the one that passed through, an angle is formed here also. And of course, this angle is called the angle of deviation. Now, can now have laws of reflection. Laws of reflection. there are basically two laws of reflection. We have the first one. The first one says the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. I repeat, the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. That is the first one. Now, the second law of reflection states that, now we have, this is our I here, this is our R. It states that angle of incidence I is equal to angle of reflection. Angle of reflection R. Therefore, we can now have that from that second law, angle of incidence is equal to angle of reflection. That is the second law. Now we can have this. So if this ray were to pass through, now we can have that for us to find the angle of deviation, we have that deviation is equal to. Now, if we cut this side off, we discover that this is angle on a straight line. This side is angle on a straight line. That means from here to this place must give us 180 degrees. So for us to find this D, the angle of deviation, which is from here now down to this place, we now have I plus, we add all these things, excluding this one, I plus R plus D. I plus R plus D will give us, which is angle on a straight line. Angle on a straight line is 180 degrees. Now, we can have that I, since I is equal to R, therefore, we can now say I plus D is equal to 180 degrees. Now, we can have these 2I, I plus I is 2I, plus D equals 180 degrees. Now, we want to find D, so we make D the subject. If we make D the subject, we push this other side. We now have that D is equal to 180 degrees minus 2I. So this 2I is our angle of incidence. Remember, I plus this, I plus R is still there. Because of that's from our second law. Since I is equal to R, we have 2I here, which is equal to D. Now this is our formula. Now let us take one or two calculations. But before that, we also have, assuming we have just this side, I and D. Most times, from past exam questions, they might give you angle of glance. So this is the angle of glance. Most times we don't use angle of glance. If you remove angle of glance, what is remaining is incidence angle. Therefore, we can now say that angle of glance plus angle of incidence is equal to 90 degrees, which is from here to here is equal to 90 degrees. So in other words, if we want to find I, angle of precedence is equal to 90 degrees minus angle of glance. So we should take note of this. Take note of this, because this is the one we're going to remember. We have this as our angle of precedence, angle of glance, angle of reflection, and then we have this as our angle of deviation. So let us take one or two calculations involving this. We have the first question here. The diagram above shows a ray of light IK, incident on a plane mirror at K. Calculate the angle of deviation of the ray after reflection. Now we have the second one here. A ray of light strikes a plane mirror at a glancing angle of 50 degrees. Calculate the angle between the incident and the reflected ray. Now, the solution. The first one, since we have a diagram like this is the plane surface. Now, this is the ray IK. Now, remember, the first thing we do is we draw a normal line. This normal line, this shows a perpendicular line, 90 degrees here, 90 degrees here. Now, if here is 35 degrees. Now, the question here is calculate the angle of deviation. The G is given to the 35 degrees. Now, how do we get, the first thing we do is to get our I. Remember, this continues. If it continues like this is our reflected ray. The angle of deviation we are looking for is from here to here, which is the deviation. Remember, this side is our angle of reflection. Now, since we have this, now have that, recall our second formula. Our second formula says that angle of incidence is equal to 90 degrees minus angle of glance. Therefore, I is equal to 90 minus 35, which is 55 degrees. Now, I is 55. Now, we can now use the second formula that says D, or using the relation that says D equals 180 minus 2I. Now we can now bring in this and say 180 minus 2 times I. I is 55 degrees. So which would that give us? 180 minus 2 times 55. 2 times 55 is 110. Now D will therefore D will now give us 180 minus 110, which will give us 70 degrees. Therefore, the angle of deviation is 70 degrees. Now we will now solve the second one. Now for the second one, we are given that the ray of light strikes a plane mirror at a glancing angle, almost the same pattern. This is the plane mirror. We have our normal line. It strikes the plane mirror at a glancing, remember, glancing angle, not incident angle. Glancing angle of 50 degrees. Now, if here is 50 degrees, of course, I will give us what? Remember, when here is incident, this side is reflected. Here is our R. This side is the glancing angle. The question here is calculate the angle between the angle of incident and the reflected, between the incident ray and reflected ray. That means the angle they want us to find is just here, from here to here only. And how do you get from here to here? Just add this and this. The first thing to get, since our G is 50 degrees, therefore our I is equal to 90 minus 50, which is 40 degrees. Now, having gotten our I to be 40 degrees, we can now say that this plus this, I plus I is equal to, our I is 40 degrees. Remember that, recall that from the second law of reflection, I is equal to R. Because of that, we now have, since I is 40, R must be 40 degrees. So we have 40 plus 40, which will give us 80 degrees. So the angle between here and here is 80 degrees. Okay. Okay, we have this last one. A ray of light makes an angle of 60 degrees with the plane mirror. What is the angle of reflection? Now, this is left for you to solve. Please, solve this. I need the answer on the comment section. Don't forget to like, share, and then subscribe to this channel. Thank you very much.